So we're going to review in this video balancing and then also how to write chemical reactions when given the reaction in words. Okay? So remember, when we're balancing, the reason why we're balancing is we're following the law of conservation of matter, which tells us we cannot create or destroy matter. So however many atoms you start with of an element, you need to finish with that many atoms. So let's look at this example. S8 reacts with oxygen to produce sulfur dioxide. Okay? I've got 8 sulfurs on my reactant side, so I need 8 on my product side to follow the law of conservation of matter. So I'm going to put an 8 in front. Okay? That gives me 8 sulfurs on both sides because it's going to be 8 times the implied one that's after sulfur. The 2 here only applies to the oxygen. Okay? So now, since I have an 8 in front of SO2, that means I have 8 times 2 oxygens, which is 16. So I need to put an 8 in front of oxygen on my reactant side so that I have the same number of atoms, 16, on my reactant and product side. For the next one, I've got 1 iron, I'm good with that. 1 silver, I'm good with that. But notice I've got 1 nitrate here, keep the nitrate together, 2 nitrates here. And so what I'm going to need to do is put a 2 in front of silver nitrate in order to have 2 nitrates on both my reactant and product side. By putting a 2 in front of silver nitrate, though, that gives me 2 silvers. So what I'm going to have to do is put a 2 in front of silver on my product side, and that will balance my reaction. Okay? Let's work on actually writing out some reactions now. So this tells me I have iron 3 chloride reacting with sodium hydroxide to form iron 3 hydroxide and sodium chloride. So I'm going to have my workspace over here for showing how to write out, because all 4 of these are ionic compounds. So let's show my crossing of charges. So I've got iron that has a 3+ charge, and I've got chlorine. Remember, chlorine is a 1- charge. So when I cross my charges, what that'll create is iron FeCl3. So that's one of my reactants. That's going to react with sodium hydroxide. Well, sodium has a 1+ charge. Hydroxide has a 1- charge. So when I cross my charges, that simply becomes NaOH. Okay? And that forms iron 3 hydroxide. So iron still has a 3 charge. Hydroxide is one of my polyatomics, 1-. So when I cross my charges there, that becomes Fe. And then I want 3 hydroxide, so I've got to put hydroxide in parentheses. Okay? And then the last one is sodium chloride. Na has a +1 charge. Cl has a 1- charge, so this is going to become NaCl. Okay? So that's my reaction. I now just have to balance it. So I've got 1 iron, 3 chlorines, 1 chlorine. So I've got to put a 3 in front of NaCl. Now I've got 3 sodiums, so I'm going to put a 3 in front of sodium hydroxide here. Now I've got 3 hydroxides, and I have 3 hydroxides. So I am now balanced. All right, potassium reacts with magnesium bromide to form potassium bromide and magnesium. So I'm going to write this out. Okay. Give myself a little bit of workspace if I need it. Potassium can be by itself. It's not one of my diatomic elements, so I can just write K. It reacts with magnesium bromide, so I've got to cross my charges here. Magnesium has a 2+ charge. Bromine has a 1- charge. So when I cross my charges, I get MgBr2. Okay, and that forms potassium bromide. Potassium has a 1+ charge. Bromide, as I noted, has a 1- charge, so that's going to be KBr. And magnesium. Okay, so now I need to balance. I've got 1 potassium on my reactant side, 1 potassium on my product side. I'm good with that. 1 magnesium on my reactant side, 1 magnesium on my product side. I'm good with that. But I have 2 bromines on my reactant side and only 1 on my product side. So I'm going to have to put a 2 in front of potassium bromide. That now causes me to have 2 potassiums, so to balance, I'm going to put a 2 in front of potassium, and I'm good. All right, let's look at the last problem. Solid aluminum chloride is formed when elemental aluminum is burned in chlorine gas. So notice the wording of this is a little bit weird. It's telling me that aluminum chloride is formed. So aluminum chloride is actually going to be my product, and my reactants are going to be aluminum and chlorine. So aluminum is burned in chlorine gas. Well, remember, I can't just write this as Cl because Cl is one of my 7 diatomic elements. So it's going to be Cl2. Aluminum's fine being by itself. It's not diatomic, but chlorine is diatomic, so it cannot exist by itself. Now I've got to figure out the formula for aluminum chloride. So aluminum has a 3+ charge. Chlorine has a 1- charge. So when I cross my charges, I get AlCl3. Okay. Now I've got a balance. I've got 1 aluminum, 2 chlorines, and 3 chlorines. So the only way to make 2 and 3 equal to each other is to make them both equal to 6. So for my reactant side, if I put a 3 in front of chlorine, that'll make it 6. And if I put a 2 in front of aluminum chloride, that will make it 6, because 2 times 3 is 6. But that does mess up my aluminums. I now have 2 aluminums on my product side, so I'm going to need to put a 2 in front of aluminum on my reactant side.